Section 8.1, Adding and Subtracting Polynomials. A monomial is one number, variable, or the product of variables with positive exponents. So a monomial is one number, a variable, or a product of variables and numbers with positive exponents. Examples of monomials would be 5x negative 7xy, or 0.5x to the fourth. Notice that none of these have a add or subtraction symbol in them, so they are single-termed items. Ideas of not monomials would be negative 0.3x to the negative second because of the negative exponent, 4x minus y because it has the subtraction sign in there, so it's two terms, and then 2 divided by x to the third. It's a division, it's not the product. That would be the quotient, so that one doesn't work either. The degree of a monomial is the sum of the exponents of the variables. A constant, or in this case a single number, like in this case 5, has a degree of 0. So in our first 4 examples, they just want us to find the degree of each monomial. So in example 1, we're just going to add the exponent pieces. So 4 plus 3 is 7, so this has a degree of 7. In 2, the e has an exponent of 1, even though it's not written. The d has an exponent of 1 as well. So we've got 1 plus 1, so our degree here is 2. In 3, we have k squared, we have m to the first. So 2 plus 1 is 3, so this has a degree of 3. And then 4, this is a constant. It's a single number without a variable. So that means its degree is just 0. Anytime there's not a variable, your degree is just 0. Just as you can perform operations on numbers, you can perform operations on monomials. To add or subtract monomials, combine like terms. So this means we're looking for items with the same variable or the same variable with the same exponent, and we're combining the coefficients. The variables themselves will stay the same, just the coefficients change, or the numbers in front of the variables. So for the first one, we want to combine like terms. So we've got p to the third and p to the third, so these are like terms. So we're going to add the coefficients, or the numbers out in front. So we've got 12 plus 8, p to the third. Well, 12 plus 8 is 20, so we end up with 20 p to the third as our new monomial. We'll do the same thing in 2. We've got 5x squared minus 3x squared. The x squareds are like terms, so we'll subtract, in this case, their coefficients. So 5 minus 3 gives us 2, so we've got 2x squared as our new monomial. Here we're doing the same thing, we just have more terms. So we go through and we look. We have 3t squared minus 4t squared minus t squared. They're all t squared, so they're all like terms, and we just want to add or subtract the coefficients. So 3 minus 4 is negative 1, minus 1 is negative 2, so we've got negative 2t squared as our monomial. Same thing in example 4. We've got m squared n, 4m squared n, or sorry, 10m squared n plus 4m squared n minus 8m squared n. The m squared n portions are our variables, and since they're all the same, we're just going to combine our coefficients. So 10 plus 4 is 14, minus 8 is 6. So we've got 6m squared n as our new monomial. A polynomial is a monomial or a sum or difference of monomials, aka multiple monomials. So a polynomial is it could be one monomial or multiple monomials put together, separated by the addition and subtraction symbols, creating different terms. The degree of a polynomial is the degree of the term with the greatest degree. So to find the degree of a polynomial, you're looking for the monomial term with the highest degree. The standard form of a polynomial is written with the terms in order from greatest degree to least degree. And then this chart just shows us a box of how we name polynomials. If there's only one term, it's a monomial. If there's two, it's binomial. 3 is trinomial. And then 4 or more is automatically designated as the generic term polynomial. We want to write the polynomial in standard form and then give the degree and name it based on the number of terms. So for the first one, if I look at my item here, I've got y squared plus 6y minus 3y. I notice that my first y squared here has a degree of 2, y to the 6 has a degree of 6, and then 3y has a degree of 1. So I want to rearrange these so they're in order from greatest to least degree. So that means I have y to the 6th plus y squared minus 3y. And then we want to name it, and then we want to figure out its degree. Well, its degree would be the largest one, so in this case it has a degree of 6. And then I want to name it by the number of terms. Well, there are 3 individual terms here that are separated by the 2 addition-subtraction signs. So 3 terms tells us we're dealing with a trinomial. We'll do the same thing in the next one. We've got 16 minus 4x squared plus 5x to the 5th plus 9x cubed. 16 has a degree of 0, 4x squared has a degree of 2, x to the 5th has a degree of 5, 9x cubed has a degree of 3. So let's order these from greatest to least. So we've got x to the 5th plus 9x cubed minus 4x squared plus 16. Our degree is the highest degreed monomial, so that's 5. So we have a degree of 5. And then because we have 4 terms, this is just going to be a polynomial. All right, in the next example, we're doing the same thing. We've got 18y to the 5th minus 3y to the 8th plus 14y to the 5th. Before we start determining degrees, we should notice that we have like terms here. So to make this easier, we're just going to simplify it. We're going to combine like terms. So in reality, we've got 32y to the 5th minus 3y to the 8th. Now we'll look at the degrees. We've got 5, we've got 8. So we rearrange these from greatest to least. So that means we've got negative 3y to the 8th plus 32y to the 5th. Our degree is 8, and we only have 2 terms, so this is a binomial. Now we're talking about adding and subtracting polynomials. So we've got multiple terms, and there's a lot more to keep track of. And so now as we go to add and subtract polynomials, the idea here is still the same. You're combining like terms. So we have 3a squared minus 6a plus 7a squared minus 10a. Right off the bat, I know that the 3a squared and the 7a squared are like terms. So all I'm going to do is combine like terms. I add the coefficients. 3 and 7 becomes 10a squared. Then I go negative 6a and negative 10a are like terms as well. So I'll combine those, and I've got negative 16a. So this becomes my answer. 10a squared minus 16a. We'll do the same thing in the next one. We've got 10xy plus x plus negative 3xy plus y. So right off the bat, I know that I have like terms in 10xy and negative 3xy. Combine my like terms. I've got 7xy. And then I notice that the x and the y are not like terms, so I'm just going to tack those onto the end. So plus x plus y. And so this becomes my new polynomial. I do the same thing in 3 and 4. I've got 4m squared plus 5 plus m squared minus m plus 6. right off the bat, I know that I've got 4m squared and m squared are like terms, so that gives me 5m squared. The minus m doesn't have a like term, so we just add it in there because it has nobody to combine with. And then I've got the 5 and the 6 are like terms, so I add those together and I get 11. So my final answer becomes 5m squared minus m plus 11. Example 4, very similar. 6x squared minus 4y plus 3x squared plus 3y minus 8x squared minus 2y. So here I've got 6x squared, 3x squared, and negative 8x squared. I'll combine like terms. 6 and 3 is 9, minus 8 is 1, so I've got x squared. I've got negative 4y, and I've got 3y, and I've got minus 2y. Negative 4, positive 3 is a negative 1, minus 2 is negative 3y. So I've got x squared minus 3y is my final answer. To subtract polynomials, remember that subtracting is the same as adding the opposite. To find the opposite of a polynomial, you must write the opposite of each term in the polynomial. So when they show us subtraction and they put parentheses out in front of the polynomial with the subtraction sign out in front, like they have here, you've got to distribute this subtraction throughout before you start combining like terms. So in this first one, we've got x cubed plus 4y minus 2x cubed. So we're going to distribute that there. So what happens is we can kind of leave the parentheses out of it now. And this is how our problem looks. Well, right now I know I have like terms in x cubed and negative 2x cubed. So when I simplify this, I've got negative x cubed plus 4y as my final answer. I'll do the same thing in the next problem. 9q squared minus 3q minus q squared minus 5q. I'll distribute the negative. So I've got 9q squared minus 3q minus q squared plus 5q. Now I can begin combining like terms. 9q squared minus q squared is 8q squared. And then negative 3q and positive 5q are like terms. And so when I combine those, I get plus 2q. And so that's my answer. All right, our last two problems. 7m to the fourth minus 2m squared minus the quantity 5m to the fourth minus 5m squared plus 8. So to start off with, I'm going to distribute the negative. So 7m to the fourth minus 2m squared minus 5m to the fourth plus 5m squared minus 8. So my like terms right off the bat, 7m to the fourth, negative 5m to the fourth. So that's 2m to the fourth. Then I've got negative 2m squared and then positive 5m squared. So that gives me 3m squared. And then last but not least, we've got the negative 8, which we'll just tack on the end here. So our final answer becomes 2m to the fourth plus 3m squared minus 8. So question 4, we've got 2x squared minus 3x squared plus 1 minus x squared plus x plus 1. So we're going to distribute the negative throughout the second quantity. So I've got 2x squared minus 3x plus 1 minus x squared minus x minus 1. I'll combine my like terms. I've got 2x squared, negative 3x squared, and then negative x squared. So 2 minus 3 is negative 1, plus another negative 1 gives us negative 2x squared. And then we continue combining like terms. I've got just one negative x here. So I've got minus x. And then I've got positive 1 and negative 1. Positive 1 and negative 1 cancel out. So my final answer ends up being just negative 2x squared minus x.